Hi guys, this is our second video. This is problem 7.89. Let's walk through how to solve it. So we have three cascaded edge-triggered D flip-flops, and they're all activated by this clock, and you see this little triangle, which means it's the edge and not the absolute value of the clock. And if we just look at one edge-triggered D flip-flop, what happens is that this output Q becomes D when the rising edge of a clock were to occur. Alright, so if this was 1, this was 0. If the clock edge happens, then this becomes 1. If this was 0 and this was 1, then if this edge happens, then this becomes 0. And if this was 1, this was 1, and the edge happens, then it just stays the value, whatever it was. Okay, so they give us some initial values. Q0 is 1. Q1 is 0, Q2 is 0, okay, and so that looks like, so if we were to draw that, let's just put D0 here, Q0, Q1, and Q2, and so that means Q0 is 1, that means it's a 1 here, and I see an edge, and Q1 is 0, and Q2 is 0, okay, and they want to know what the pattern looks like with time, and so let's put our time axis on this horizontal axis. And they also want to know, when does this initial condition repeat? When do we see 1, 0, 0 again after all these clock cycles? And they give us this square wave clock cycle. What else do we see? We see that it's kind of the dog chasing its tail, where we got this exclusive OR up at the top. And what does the exclusive OR mean? Exclusive OR means that if only one of these inputs is true, then the output is true. If they're both false, then this is false. If they're both true, then this is also false. Okay, so we actually can find out, based on exclusive OR, what the initial D0 is. So what do we have? Q1 is 0. Q2 is 0, so that means that D0 is equal to 0 by the exclusive OR, because they're the same. Alright, so that means this is 0 down here. So this is our starting condition. We have all these edges here, and when the edge occurs, because they're all in parallel, all of them shift over. So when I say all of them shift over, I mean that Q0 becomes D0, Q1 becomes D1, and Q2 becomes D2. And we also note that, look, Q0 and D1 are the same, and Q1 and D2 are the same, and then Q2 feeds into the exclusive OR. So basically everything just shifts over every clock cycle. And so let's do this first one together. So what do we have? We have a clock cycle here, so that means Q0 becomes whatever D0 was, so that means it was 1, it's now 0. Q1 becomes whatever Q0 was, and so it was 1, so now this was 0, now it goes to 1. And then Q2 becomes whatever D2 was, or Q1 was, and it's 0, so it actually stays 0. And now we can find out what the new value of D0 is based on this exclusive OR. So 1, 0, exclusive OR, that's a 1. So this jumps up to 1. Okay, let's do the next one. Next clock cycle occurs right here, and so we go, okay, not bad. 1 becomes 1 for Q0 here. 0, it cycles down to 0. This cycles down to 1. Alright. And we do an exclusive OR between Q1 and Q2 to get the new D0. 0 and 1, that's still a 1. Okay. We keep going. 1, 1, 0. Again, the exclusive OR, 1, 0, we get a 1. Keep going again. 1, 1, 1. Now we have a 1, 1, so now this becomes 0 by the exclusive OR. Next we have 0 this time, and this is 1, and this is 1. Okay, 1, 1, again we stay at 0. And then 0, 0, 1. Okay, 0, 1, we get a 1. Then what do we get? We get 1, 0, 0, and 0, 0 becomes 0. And we look, this is the original initial condition, and finally we've hit the repeated pattern. That's the next question. When does the initial condition repeat? And we go 1, 2, 3, 4, 5, 6, 7. After 7 clock cycles, we actually get a repetition. And we can see that the D0 goes up for 3 cycles and comes back down, up, and then the pattern repeats. And the same thing here, 3 and then 1. Here's the 1, we get 3, okay, and then we get this little blip, and then we get this 3. And so you can see that shift registering action going on as every register shifts over, and you got, if you keep going, it'll just repeat itself. Let's take a look at the circuit sim. So if we switch over to circuit sim, we can see what's going on over here. And again, I have this exclusive OR built out. I have 3 cascaded shift registers. I have a clock that's pulsing, and you can see the clock going. That's this first scope line up here. And then I have D0, Q0, Q1, Q2 just as before, and you can see what as I go through here it highlights. Now I also have this special little OR gate, and what that allows me to do is to preset. So let me just run and stop this and reset everything to nothing. And so if nothing is set, this is just going to propagate 0. So here's the clock, and I have it at a very slow clip. So it's just going 1, 0, and just ticking along. Okay? And if I just hold down this high, it's going to preset this 1. Otherwise, it just passes through whatever was left if this is a low, right? Q equals the output if this is a low. So let's just hold this down. Okay? And so now what I have is essentially the initial condition right here. And everything is going to propagate forward. And so what happens, so we have a 1 here. When the next cycle happens, we get a 1 and 1. When the next cycle happens again, we see a 1 here. That's going to propagate over, and we're going to have this go to 1, this go to 0, and then we have 1, 0. This should stay 1. Sure enough, it does. Good. And if we speed up the clock, so if I go from 10 hertz to, let's say, 100 hertz and apply, this will go much faster. And you can see the clock is ticking away right here. And let's just let it kind of fire off at least 8 cycles. And then I'm going to pause it over here. And if I pause it, let's find the one where it started with in our when we did on paper. We had 0, 1, 0, 0. That's this one. Okay, and how many cycles? We did 7 cycles. So 1, 2, 3, 4, 5, 6, 7 before it repeats again, and we check 0, 1, 0, 0. Sure enough, it repeats. We see this pattern of 3, 3, 3 shift register down. So hopefully this is consistent with what you get on paper. Okay, thank you much for listening, and I hope this helped. All right, I'll see you in class.